Okay, so Kayla says, let's see number 30. All right, number 30 and number 32 are similar. 32 just a little bit more tricky. So let's look at this. Number 30. All right, so number 30 says, first of all, number 30, it gives us the equation. I believe g of x is equal to 2x squared plus 18x plus 14 minus 14. All right. What part A asks us to do, all right, is to find g of 9. All right. So since we're finding g of 9, actually, I'll rewrite that down. We're finding g of, let's make that red 9. Okay. So we have g of 9. All right. So what that's saying is, all you're doing is, instead of having g of x, where you have x's, you're going to have 9s. So g of 9 is 2 times 9 squared plus 18 times 9 minus 14. You type that into your calculator, and you're going to get 310. All right? That's good. Right. So that way we know, okay, we are plugging that 9 in. Okay. So, in this problem, that's pretty much all you're doing, except in part B and C, it gets a slightly bit trickier just because it has the whole 3x and 1 plus 5 thing. So if we look at part B, it says g of 3x. All right. So we're going to have, this is equal to 2 times 3x, that's squared, plus 18 times 3x, and then minus 14. All right, so again, we plug that in, and we have to simplify this now. Okay? So in here, it's 3x squared. Well, 3x squared, that's the same as saying 3x times 3x, which is equal to 3 times 3 is 9, x times x, which is x squared, so you 9x squared. So this is 2 times 9x squared. Okay? 2 times 9x squared plus 18 times 3x, so that's just 18 times 3, which is going to be 54, x minus 14. That's just going to be equal to, I have to simplify this last part, 2 times 9 is 18 with the x squared plus 54x minus 14, and that is our answer. Yes.
So when you put that in the calculator, like, when you put the variable x where, like, it would come out with that.
So if you put the variable x in there, with your calculator, it's a brand new calculator, I'm not sure what would happen, but typically what I'll show you guys later on is you can actually store numbers in your calculator. What happens is you can, a lot of times you can store x as a number. So you can store a number as x. So what happens is, if you were to type this in, all right, let's say from like back in the day, the last time someone stored a number as x, it said store, someone stored 5 as the number 5 is x. That means x is 5. So if you were to type this into your calculator, it would just be 18 times 5 squared plus 54 times 5 minus 14. So it all depends on what x is. All right. So like for instance, I have it right here. I can show you on this calculator right here. So what I can do is I can take this and go. I can say 2 store x. So I can go 2 store x, hit enter. So now x is the number 2. So essentially I just go 18 x squared plus 54x minus 14, and it gives me the number 166 because 18 times 2 squared plus 54 times 2 minus 14 equals 166. All right. So so typing in x, you don't want to do that when you have these like variables where you have that you're putting a variable into the equation. Now up here, the easy way you can do this is, so let's say you want to evaluate that at 9, but you want to be careful of the way you plug it into the calculator. You could go 4, not that. You go 9 store x. All right. So now 9 is x. So I can go second enter, which gets me up to this. Hit enter. Oh, not 54. It's a different bubble. Up here, I typed it in wrong, but it'd be plus 18 and 2 times 9. So I typed it in wrong in the calculator, but you can just type it in and tell you the other intent. All right. Now, the second one here, or the third one, it is C. It is G of 1 plus 5m. Okay, where that would be so in this case you would have 2 times, I'm replacing x with 1 plus 5m. All right, and I'm squaring that plus 18 times 1 plus 5m. Alright, and then minus 14. So this one's going to have a lot of simplification that you have to do. Way to distribute stuff. So what you actually end up getting is you get 2, so 1 plus 5m squared. I do that off to the side, so I have 1 plus 5m times 1 plus 5m, which is going to be 1 times 1, which is 1. 1 times 5n, which is 5n. 5n times 1, which is 5n. 5n times 5n, which is 25n squared. That is 1 plus 10n plus 25n squared. I did that kind of fast, but hopefully we all understand that. So what I do is I take this whole thing and plug it in over here, back in for 1 plus 5n squared. 1 plus 5n squared is equal to that. So I have 2 times 1 plus 10n plus 25n squared plus. Then I'd have 18 times 1, so that's 18. 18 times 5n, that's going to be 90. So that's going to be 90n. Minus 14. And then you have 2 times 1, which is 2. 2 times 10, which is 20m. 2 times 25, which is going to be 50m squared. Plus 18, plus 90m, minus 14. You combine everything, and you get 2 plus 18 is 20 minus 14, that's 6. 20m plus 90n is 110m, and then I have plus 50m squared. And assuming I get all my math right, I believe that's the answer that I had. Yep, except I had it written backwards. So this is the same thing as saying 50m squared plus 110m plus 6.
Right, so now when you number
40? Okay. Alright, so that's it the same, you do the same thing with 32, except for 32, you're gonna get stuff in the numerator and denominator, so there's a little bit more substitution. Okay? Other than that, same sort of process. One's with all numbers, one where it's only a one term, and then one with a binomial number. Alright? So 40 is a problem where we are trying to find the domain of a function. Alright, so we have 40, we have g of x is equal to x plus 1 over x squared minus 3x minus 40. Okay? Now, here, we have to remember, alright, going back to Friday, what our domain is the values for x that we can plug into this function. So what we want to do is figure out what values x cannot be. So there's two major restrictions that we have on our domain. Alright? Which the restrictions being square roots, because it can't notice we can't have negatives. Can't have negative number underneath the square roots. Alright? And the other one is the denominators. Denominators can't be equal to what? Denominators can't equal 0, ever. Okay? So since now we have x plus 1 divided by x squared minus 3x minus 40, which part of this is our denominator? Bottom. Alright, denominator is on the bottom. So what that tells us is x squared minus 3x minus 40 can't equal 0. Okay, it can't. Okay, well, anytime I say a quadratic function in the denominator, the first thing you should do is automatically think, okay, maybe I can factor this. Okay, so in order to factor this, anyone remember how we factor a quadratic function like this? Huh?
On 3 and 4, are you doing that, or?
We were looking at 3 and 40, so first of all, what's the leading coefficient? 1. So automatically I know that's going to be x and x right here. Alright? Then I need to find the factors of negative 40 that add up to negative 3. So if I'm thinking just about the factors of negative 40, okay, I'm thinking, okay, I got the 4s and 10, I got the 8s and 5s. The 8s and 5s are 3 units apart. And I know one's going to have to be positive, one's going to have to be negative because this is a negative 40. So I know that's most likely the number that I have to work with. Because they're 3 units apart, I'm going to be adding one's going to be positive, one's going to be negative. So I have negative 8, 5, 8, negative 5. If I add these numbers, which one of these will give me negative 3? Negative 8 and 5. So I put minus 8 and plus 5. Okay? And I know that this cannot equal 0 still, because this is just another way to write that denominator. Okay? Now, if I plug in a number, if I plug in 2, this is going to end up giving me a number times some number. What must be true about one of these numbers in order for it to be 0? One of these factors, when I plug in a number, has to be 0. So if I plug in 8 right here, it's going to give me 0 times 3, which is 0. That's not good. If I plug in a negative 5 here, it's going to be negative 13 times 0. That's 0. That's not good because it can't equal 0. So the way I figure out those numbers, I go x minus 8 equals 0. Add 8. Add 8. Well, x minus 8 can't equal 0. So x cannot equal 8. X plus 5. cannot equal 0. Subtract 5, x cannot equal -5. Okay? So now what I'm going to do is I'm going to do this only because I want to visualize it for you guys. Okay? I'm going to draw a number line. I need to find my domain. Okay? I know x cannot be -5, and it cannot be 8. Cannot be. Can it be everything else though? Be anything else. It just can't be what my x's are that I have right here. Alright, so my domain is equal to negative infinity, way down here, all the way up to -5. Or any number between -5 and 8. Right, or 8 to infinity. And one of the big corrections I made on a number of people's homework is it's always the smaller number on the left side of the parentheses, and it's always the bigger number on the right side of the parentheses. Infinity and negative infinity always will be like on the outside of the parentheses. That's the answer. There's your domain. So what that tells me is that x can be any number between negative infinity and -5. It can be any number between -5 and 8, and it can be any number between 8 and infinity. Okay, does that help?
Yes, a lot.
A lot? Okay. Anyone else have any other questions? Now, I will say this. Initially, I was planning on being here until 3:30 after school to offer tutoring. Unfortunately, they've decided that I need to go to a staff meeting after school instead. So what I will say is, unfortunately, I can be here from 6 to 8. So I will probably be sitting here in my room with my feet on my desk, listening to music, with nothing to do from 6 to 8. Now, I know most of you guys don't want to come back and get help from 6 to 8, but I will be here if you do need help. I'll be coming in here and get help. I'll be like, oh my God, there's someone calling. So I will be here from 6 to 8. Maybe don't be here right at 6 because I'm most likely going to be stuck in traffic on the way back. But again, I will be here from 6 to 8 if you do want to stop by and get help if you're around in the neighborhood or whatever. So, yeah. All right. Now, any other questions? Then you just need to show of hands. Do you think you need maybe more practice on domain or domain like this? Yeah? Okay, so let's do some more practice. So what I want you guys to do is we're going to probably push back a little bit what we're going to do. So hold off on this for a second. Let's see. Last time you guys all the problems for this evening. I said evenings, there's a reason because the obviously answers are in the dark. All right, so what we'll do is we'll look at. Oh, wow. All right. So we're on page 9, correct? And we did which numbers are the domains for 40? So let's look at some of these ones up here. Yeah, 39. We'll do 4. Okay. 39 through 45. Okay. And we're going to do that. Which ones did I give you guys? Oh. I'm going to take it. 18 through 40. 40. Okay, so you had the number. Okay. All right. So we'll look at 39, 41, 43, and 45 because Those ones are each similar to the even one across the one that you were, the even one that you're supposed to do. Okay? Now, see, now you guys need extra help. You need to let me know. Alright? So I was gonna plan on going forward and you guys sound like maybe you want some more help. Alright, my benefit. So we go over these, again, write down the problem, work through it. I'm gonna ask you guys questions. I'm not going to just tell you the answers. I need you to help me think through it. Okay, so the first problem that we'll look at, and again, guys, these are going to be very similar to the ones that you guys are going to do at home. We have 39. So f of x is equal to 8x plus 12 divided by x squared plus 5x plus 4. Okay? So again, what you guys are working on is right now, there are pretty much only 2 times that you guys are going to have problems with your domain. And they're what? Square roots and denominators. Alright? Square roots and denominators are going to be where your guys' problems happen. That's where we have issues. Alright? Those issues meaning square roots can't be negative, so we can't have a negative number underneath the square root, so they have to be greater than or equal to 0. And denominators, they just can't be 0. Okay? So, does this have a square root in it? So I don't need to worry anything about square root. I'm not dealing with that right now. Does it have a denominator in it? Yes. So now I have a problem. So I look at this and it says x squared plus 5x plus 4. And this cannot equal what? Can't equal 0. So I don't care about the numerator. Right now, with what you guys are learning right now, I don't care about the numerator. Later on, we'll start talking about the numerator and because it can cause some problems too. But right now, I don't care about the numerator. I'm looking at the denominator. Okay? This is a quadratic function. 99% of the time, when you have a quadratic function, you're going to want to do what with it? It's factoring. I don't want to say every time because then it's like one time it won't actually be factored. But when you guys are looking at stuff that looks like this in this class, it is probably, the bottom will probably be able to be factored. Not always, but the first thing you should do when you see a denominator is say, I want to factor it. Okay? So, to factor this, what do I do? What number do I, well, first of all, 1. My leading coefficient is 1, right? So I know right off the bat, okay, that's cool. So that's just going to be, x, x. Also, I know this times this can't equal what? 0. Okay. So, now I need to find the factors of what? And I need to find the factors of 4 that add up to what? 5. So, factor of 4 is easy. Okay, here's a little trick. This is a positive 4, right? This is a positive 5. I don't want negative numbers if I have 2 positives. Right? Because the factors of 4 are 1 and 4, 2 and 2, and then negative 1, negative 4, negative 2, negative 2. If I add these, those are giving me negative numbers. Well, definitely don't have negative numbers. I know those are not good. Which of these have is 5? 1 and 4. So I'm going plus 1, plus 4. Okay? Alright. Well, I know either this factor can't equal 0, or x plus 4 can't equal 0. Okay? So, how do I figure out what x is? I add. Subtract 1 from both sides. I get x cannot equal negative 1. Over here, I subtract 4. I get x cannot equal negative 4. So then, if it helps you, first I want to do it because I've done this enough. But, yes, do the number line. Draw a picture. Drawing a picture always can help. So, you just make a number line. That's straight. Alright, and what do? You place your numbers on the number line from least to greatest. Alright, and you can even do this. You can go, hey, I know negative infinity is way down here. That's why I put the arrows one on whatever. Alright? Then I have -4, -1. Alright, so 1, -1. And then that's it. I have infinity way down there. That I know it cannot be. It's not negative, can't be -4, it can't be -1. I know negative infinity and infinity is just parentheses because it can't actually be those numbers. So my domain is equal to what's my first interval? To negative what? -4. Are these both parentheses? One parenthesis, one bracket? Both parentheses because it can't be -4. So it's negative infinity to -4. What's that? Union. And then what's my next interval? -4 to 1. -1. I can't just jump and say, okay, -1, that's my next number that I said over here. I can't forget about these numbers in here because they kind of want to be part of the party. Alright? So -4 to -1 and -1 is it. And then you're done. A little bit more clearer. I'm thinking what I may do is create some more problems like this if you have extra practice if you want to do it. And also give you extra practice for factoring if you want to do it. Factoring will be important. I'm doing right now. Alright. Old white people. So, let's look at 41. 41 says it's a little sneaky here. Let's go ahead and do it all the way through. It says g of a is equal to the square root of a squared. Okay. Now, we're going to look all the way through this and do it just like you normally would, but then we're going to also look at this as a shortcut real quick. Okay? So first of all, it's the square root, right, Michaela?
Yeah.
So what type of number can we not have underneath the square root? We can have 0. We just can't have negative. We can have 0, and we can have all the positive numbers we want. We just can't have a negative number. So it has to be greater than or equal to 0. So what I do is I take whatever's underneath the square root. So what's underneath the square root together? So 1 plus a squared, yes, man. 1 plus a squared. This has to be greater than or equal to 0. Okay? Now I need to get the a squared on one side by itself, so I'm going to take this 1 and I'm going to move it over to the other side. Now there's an issue here. Huh? What's a negative?
Saying that a squared is greater than
Can I square something and never get a negative number? Right now, it's saying that a squared could potentially be -1. Can a squared ever be -1? Wrong. It can be I. I squared is -1, but we actually got it. So, but We're talking about real numbers, which is what we do. Whenever you square something, it's going to be positive. You cannot get a negative number when you square a real number. So at this point, here's what you get is a can be whatever it wants. A squared is always going to be positive, correct? Okay, so since a squared is always positive, this can never happen. Okay? Because a squared minus a squared is always going to be greater than -1 every time. So there's no problems with this domain. A can be any number, negative infinity to positive infinity. Why? I can choose -50 million here. If I square -50 million, that's going to be 250. It might be 200. I don't know. That's too big of a number for me to think about. If I square any negative number to be positive, right? Then I'm adding a positive number to a +1. Can that ever be negative? Can never. This is never going to be smaller than 1. Because the lowest I can go is put a 0 in there. 0 squared is 0, and I have the square root of 1 plus 0, which is the square root of 1. So there's actually no problems here, and that's going to always be the fun. That would always be the case when you have a positive number plus a squared, or 3a squared, or plus 5a squared, right? So since we find out that a squared is always going to be greater than -1, what we say is our domain here is equal to negative infinity to infinity, because it can be any number we want. There is no restriction on it. Now, the next one we look at will actually have a square root where it causes issues. No. Okay? Can you?
We proved the same thing, how we did last time, and we did the next time.
Well, let me think about it. Because I do want to give you a little bit of new stuff, so new stuff's pretty easy. But I'll think about it. Like, you mean, can you turn in what was due today Friday?
There we go.
What I'll say is, if you feel like you want to go back and redo those even numbers, you can. Just show me that you attempted it today, so that way I can mark that you had it. That way I know you had it. Alright, so if you want more time, if you want till Friday to do like the even numbers, because this helps you and you want to just make sure you have it right on your homework, it's fine. Just show it to me at the end of class. Make sure that you have it. Alright? So, 43. Says 5a divided by the square root of 4a minus 1. Okay. Again, this could just be 5x. I just don't like putting a's to look at it in. So, question. Do we care about the numerator right now? Nope, we don't care about the numerator. We care about the denominator. So, we have a denominator. So the denominator cannot equal what? Cannot equal 0. Okay? We also have the square root. The square root has to be what? It has to be positive or 0, right? However, okay, so the square root can be, alright, greater than or equal to 0. But we just said it can't be equal to 0, right? Because this square root's in the denominator. So this square root right here, it has to be greater than 0. It can't actually be 0 in this case. Because it's in the denominator. Okay, so it has to be greater than 0. Alright, so what do we do here? Well, we know it can't be equal to 0, so it has to, so this is the more restrictive one. Alright, so what we'll do is, let's first off, let's look at, let's figure out what A has to be greater, or what this has to be, what A has to be greater than. Alright, so we know that this part underneath the square root, alright, is equal, so it has to be greater than 0. Okay, so how do I solve this? Well, it's like solving a couple-step equation, a multi-step equation. I'm going to add 1. I get 4A is greater than 1. I'm going to divide by 4. I'm not flipping this right now because I'm dividing by a positive, not a negative. Alright? So I get A is greater than 1/4. Okay? So A is greater than 1/4. Now, what I'm going to do is I'm going to look at, this is in the denominator. So we also know it can't, so we know this whole thing in the denominator can't equal 0. Alright? So what I'm going to do is this, because square root of 4A minus 1, it cannot equal 0. Can you guys impress me and make me happy by telling me how I get rid of the square root on the left-hand side? Squaring it. Alright? So I'm going to square it on both sides. So I now have 4A minus 1 is not equal to 0 squared, which is just 0. Okay? I'm going to add 1 to both sides. 4A cannot equal 1. Divide by 4. Divide by 4. A cannot equal 1/4. Okay. Now I want to just take our time to illustrate this like on numbers. Okay. So this says right here. This says A cannot equal 1/4. So first of all, I'm gonna put that in. Negative infinity, positive infinity. What's that? 1/4 is in there. This says A cannot equal 1/4. Alright? It means that A can be any number besides 1/4. It can be any number less than 1/4. It can be any number greater than 1/4. However, we have another one part that tells us A has to be greater than 1/4. So even though this doesn't say anything about, even though this means it could be like -4 or -5 or something down here, this tells us that it has to be bigger than 1/4. That means our number line is only the numbers that are bigger than 1/4. So our domain is equal to, alright, parentheses, 1/4, comma, infinity. Bruh. They got another paper.
You got it back.
Now, let's look at this last one. Okay. So, the last problem that we have looks challenging, but it's not challenging. Okay. So, we have this problem right here. This is the last one we're going to go over, and then we're going to start doing a little bit of stuff. This is number 45 in the book. So it's like number 46 on your homework. Yes, there's a plus sign in the middle. So it says 2 over x plus 4 over x minus 1. Okay? So, looks challenging just because there's 2 fractions up here, but not challenging. Do we have any square roots up here? I don't have to worry about anything with square roots. Nothing has to be greater than or equal to 0. Don't need to worry about that. Alright? Do I have denominators up here? How many of them? 2 of them. So this denominator cannot equal what? 0. So someone tell me what cannot equal 0. So what is it? X. Oh wait, so we're done with that one. X can't equal 0. So we're done. We've taken care of. We know X can't be 0. We didn't have to do any math there. We just write down something that halfway gives an answer. What about over here? 4 divided by x minus 1. What do we know can't be 0 over here? X minus 1 can't be 0. Okay, this isn't too hard. It's like a one-step problem. Guess when we do this? 6th and 7th grade, so we add 1. Get x cannot equal 1. Cool. Not making another line. Got my negative infinity, my positive infinity. Okay, so I have 2 numbers here that I know I'm concerned about. I'm concerned about 0, I'm concerned about 1. It can't be 0, it can't be 1. Anything else is fair game. Alright, so my domain is equal to, someone come up here and write it. Caleb. Don't worry, this little marker that I got right now makes all your hand right.
That's wrong with you.
Even her infinity looks cool.
How'd you do it? Silent speed.
We just put yeah, we got on America. America. Alright. Does everyone understand how she got the domain there? Well, I think we just solved all the domain problems, and what I'll do is I will allow you to make sure that your homework that is due today is done by Friday. However, you're going to get some more homework tonight. It's easy. Here's how I know it's easy. I think, let me ask you, I'll ask you if you thought this was easy. And you have to look the hard. Was this easy right here? I'm not talking about down here. This? That's what you're doing tonight. I think maybe. What? Alright, so, a few notes to do. Okay? We need to talk about what's called, and you guys have probably seen stuff like this. You need to talk about what are called piecewise defined functions. Okay? Yes. Piecewise defined functions. Alright, so I want you to write down this definition right now. And again, this is another type of thing where math it makes itself look challenging, but really, as long as you know how to read it, it's not that challenging, and it I think will come fairly easy for most of you guys, if not all of us. Now I say most of you because if you're absent today, then you know it's going to be challenging. Alright, so a piecewise function is a, yeah, so you guys want to get 3 extra homework on tonight. Wait,
Are we subdividing units?
just, it's, don't even worry about that, that's like ideal, but also, that unit that unit guys maybe see that is also planning for Friday will be a senior day, so that's pretty just, and, I did extra day of review, which is good, so it doesn't matter about that. That's like my, if everything was perfect and it was sunny and 75 every day, it would be cool and we'd be right on task, but it's like 95 degrees outside, so we're not on task. And also, if you look at it, if you didn't spend as much time on domain today, which it's a good thing we spent time on domain, but we would have been right on task, or right on track, had we done everything that I wanted to do. So, I was trying to make up time, but that's okay, we make up time elsewhere. Alright? Again, you guys don't worry about where we are in the unit guide, except for making sure you know what your homework is. Just let me worry about where the unit guide is, where the unit guide is. I mean, because honestly, you guys supposed to have a quiz today.
Glad.
So you guys might have a quiz on Monday. It will be domain and range, it will be piecewise, and it will also be analyzing graph functions, which as long as we know how to read graphs, we'll be good with that. So a piecewise function is a function that is defined using two or more equations for different intervals of its domain. Alright? These types of functions are very common in real world problems. A lot of times you'll see this in problems that deal with business stuff. So, let me see what's on this. So, let me explain what this means. Okay. So, a lot of times what you're going to have for a piecewise function, is this. You're going to have like f of x. Okay? And actually, we'll even do this. I'm going to take the domain that we just had over here. Let me copy that. We're going to do this. I'm going to group it. We're going to copy it. I'm going to bring it over here just so that I, can look at it so I can write a problem. Okay. Okay, so we're taking Michaela's domain. Alright? And there are three parts to this domain. There are all these numbers that are less than 0. There are all the numbers between 0 and 1. And there are all the numbers between 1 and infinity. Now, this is the domain, yes, for one whole problem. I'm using this because it's 3 parts, so I can break it up into 3 parts. So what you might see is something like this. F of x is equal to, okay, and then you're going to have a bracket. And what it's going to say is this. It's going to go, say something maybe like x, so f of x is equal to x plus 3, if x is less than 0. Okay, then it might say something like f of x is equal to x squared if x is if it's greater than, or if it's greater than 0 but less than 1. Let's say greater than or equal to 0. Okay, and then it might say it's equal to 3x plus 4 if it is greater than 1. X is greater than or equal to 1. Alright? So that's an example that you may want to have written down. Just that way you see what the idea of a piecewise function is. So what you see is that you have a function that is defined, so these are the definitions of it, alright? Using 2 or more, so in this case 3, equations for different intervals of its domain. So we're just saying, pretending this is the domain, and so if this function is defined by different pieces over the different intervals of that domain. Okay? Sounds hard. It's not hard. Okay? I tell you it's not hard, that means it's not hard. And it's just going to be challenging at first because it's new. Now, what we're going to do here is this. And there's going to be a word column up here. This word column you do not need to write down. I'm going to tell you what page number it is in your book. Okay? That way, if you're looking at your notes, you can see, you can put like WP, number, whatever, page, whatever, and then you can just go look at the actual problem and compare your notes. Okay? So, again, this domain right here, that has literally, I just threw that solely so I can make up something, so I can have actually something to make up. So that's really not necessary to the example. That's what a typical piecewise function will look like. Okay? So, how do we use this? Well, you know what? We're just going to jump right into a word problem, I believe. Okay? Go. Uh-oh. All right. So, I know that's kind of small to see. That's kind of small to see? Yeah. So I'm going to read the problem. Again, you don't need to write this down, except you just put, actually, let me tell you what page and column this is in your book. This is, so it's example 6 on page 8. So just put EX8, page, or wait, EX6, page 8. So that way, you don't have to write down the questions, and you don't have to write down the problem. Alright? Just all you have to do is write down the answers. In fact, it gives you the answers in the book, but that way you know where to go see this. Alright? So, it says, the average maximum height of children in inches as a function of their parents' maximum heights in inches can be modeled by the following piecewise function. Okay, that's a lot of whatever. You don't need to know any of that information except this is the function you're using. Alright? And this function gives the average maximum height of children based on their parents' height. Okay? So it says find the average maximum height of children whose parents have the given maximum heights. Alright? Use h of x, where x is the independent variable.
Pardon the interruption. Dewan Staples, could you please report to the main office? Dewan Staples, report to the main office. Thank you.
Where x is the independent variable representing the parent's height, and h of x is the dependent variable representing the child's height. So all it's saying is x is going to be, like, let's say it's Leilani's parent's height. Alright? So however tall they are, that's their x value. We're going to plug it in somewhere into this equation to figure out how tall she should be, like the average maximum height. Alright? So we'll do that at the end. So, this says, first question says, find the average maximum height of a child whose parents have a maximum height of 67 inches. So that's saying this kid, their parents have a maximum height of 67 inches. Alright? So, if we look at this equation, it says, I'm gonna put a bunch of words here for this equation. It says the height of this child is equal to this equation, 1.6x minus 41.6, if their parent is between 63 and 66 inches tall. So is this parent between 63 and 66 inches tall? So I'm not using that equation for this child. Okay, I'm not using that one. This child's height is equal to 3x minus 132 if this child's parent is between 66 and 68 inches tall. Is this parent between 66 and 68 inches? No. Yes. So I'm using that equation to figure out how tall this parent, or how tall this maximum height for a child is. No. using this height, or my fault, this parent's height is 67 inches, so to find out this kid's maximum average height, what I'm gonna do is I have to find h of 67. Well, 67 is between 66 and 68, so I'm using that equation. So I have to plug, so actually, I rewrite this. I'm using, I need to find h of x, when x is 67, so I'm using h of x is equal to 3x minus 132. Okay, the reason I'm using that is because 67 is between 66 and 68. So I go, this is equal to 3 times 67 minus 132. I think calculator. All right. You got that? What was it? 69. Up 69 inches. Okay. So the average maximum height, all right, of a child whose parents have a maximum height of 67 inches is going to be 69 inches. That's that child's average maximum height. That makes sense. Now, next problem says, find the average maximum height of a child whose parents have a maximum height of 72 inches. So, what do? We look at, see which interval of the domain does 72 fall under. Is it between 63 and 66? No. Is it between 66 and 68? No. Is it larger than 68? Yes. So I'm using this equation. So in this case, I'm using h of x is equal to 2x minus 66. Okay. Well, I'm finding h of this parent's height 72. So it's 2 times 72 minus 66, which is going to be, what, 144 minus 66, which is going to be, who? 78. This must be me. 78, I'm going to put inches. That'd be almost like me, that's 6'6". So, I have to take one shoulder. Questions so far? That's pretty straightforward? Your homework, instead of those extra problems that you get, instead of like having a word problem like this, it's going to give you something like, this. So it's going to have some kind of equation, and it's going to say, like, find f of 5 and f of 0.
And you're only here tonight, so you come back.
So all you're doing here says find f of 5. Well, is 5 less than 0? So I'm not using this equation. Is 5 between 0 and 1? I'm not using this one. Is 5 bigger than 1 or bigger than or equal to 1? Yep, so I'm using this one. So all I do is go 3 times 5 plus 4 equals 19. So that would be f of 5. F of 0. And I put f of 0 here for a reason, because I want to be tricky. Is 0 less than 0? No. I wouldn't use this one. 0 is equal to 0. See how it says x is greater than or equal to 0 or less than 1? So here, I would actually use this one. So f of 0 would be 0 squared would be equal to 0. That makes sense? Okay. I want you, can you guys see these equations right here? Maybe, maybe not. Shall I rewrite them real quick? You want to move up so I'll be ready? Alright, so what I'm gonna do is, I'm gonna give you guys 5 minutes. I want you guys to try to figure out the speed of the vehicle at time t equals 15, t equals 25, and t equals 245. Okay? And this is actually out of your book as well. This is underneath guided practice on page 8 as well. So this problem on page 8 as well. So you can not be down the problem. You can just put like guided practice page 8. Yep. There's no variable. You guys should be bringing your calculators to class every day.
Is that a plus side or is it not?
Where?
Right.
Here? Plus. On the dangerous side. Wow, all those big numbers and the people can code. But look at this, it's not all of them. Alright, so, let's see. Jericho, which equation am I using for t equals 15? Or t, why? Okay, so this is equal to 15. How come I'm not using 60 though? Okay, thank you. Alright, so we have 4 times 15 which actually happens to give you 60. So, jokes on everyone. But you don't use the second one, alright, but like Jericho said, the reason you use the first one is because it's t equals 15, and that first equation says t is equal, greater than or equal to 0, but less than or equal to 15. Alright? Let's see what we got. Not Lucas. Wait, so Lucas had short hair. So, yeah, so I'm gonna remember that. Your Lucas does the opposite of short. But, yeah. Well, you never know. Alright. Alright, so, Lucas, which one do we use here? 60, okay. So, now the question here is this. Someone said it. This is just a 60 here, right? Okay, so that means that the velocity is equal to 60 anytime here. So, it's just 60. So, if it's 200, it's 60. If it's 97, it's 60. Now, so in just a second. So t equals 245. All right. Which equation are we using? Last one. That's an equal 30. And let's do this just so that we can be professional here. It does say miles per hour, so let's go ahead and put miles per hour for our units here. I want you guys to get into the habit of putting units. Okay, miles per hour. Now, I put this up here, put the graph up there for a reason. I wanted you to see what this graph might look like, and I'll just talk about what this function actually means. Okay, so this is the graph of our velocity. All right. So between the time of 0 seconds and 15 seconds, what is our velocity doing? What? It's increasing from 0 to 60. Right? So in the first 15 seconds, the speed increases from 0 miles per hour to 60 miles per hour. So maybe like you stopped at the entrance ramp, and then you get on the highway and you accelerate to 60 miles per hour in the first 15 seconds. In my book, you're moving too slow at that point. In 15 seconds, you should get like at least 75. All right? Jokes because it's only 65 for the city. All right? So here, from 15 seconds to 240 seconds, the speed is 60 miles per hour. So what does that mean? Like, in terms of if I'm driving a car, what's that mean? It's a constant speed. So I'm just, cruise control. I'm going at 60 miles per hour for that many seconds. What about from 240 to 250 seconds? I'm braking. I'm sort of getting off of the entrance ramp, or getting off of the exit ramp maybe. So I'm coming down here and stopping at the stoplight after 250 seconds. All right. So what I want you guys to understand is, so moving into what we're going to be talking about Friday, we're going to be talking about, or in the next couple of days at least, I'm not 100% sure if it's Friday, we're going to be talking about how to tell when a graph is increasing, which it looks like you guys kind of already knew. It's increasing because it's going uphill. This is constant. We knew it because we were saying in terms of speed maybe, we said 60 miles per hour from here to here, that's constant speed. Well, guess what? This is a constant function right here. It's not changing. And we knew right here we're slowing down, so our speed is decreasing. Therefore, this function is decreasing from 240 to 250. So just by already understanding this as like a concept of speed versus time, you're able to do what we would say is analyzing graphs. Okay, describing where it's increasing, decreasing, or constant. This is not where you are starting this book Friday. Alright? And actually, that's not even about increasing or decreasing, so, whoops. But, you guys will be learning how to tell when a function is increasing and decreasing. And then when you go to AP Calculus, you'll even be able, or whatever your first math class is in college, and you're a senior, is you'll be learning how to tell if a function is increasing, even by not knowing what the graph looks like. Alright? So, what we're doing for homework, okay? If you're done with all the problems from last night, and you feel comfortable, your answers are good, you're good with that, you can turn that in. If you feel like you want some extra time to work on that, you can work on that tonight for homework, but you're also doing, so if you look at that paper that has your unit guide on it, and you're also doing the part that says, for September 2nd, piecewise functions 48 through 50 on page 10. It's only 3 problems, 48, 49, and 50 on page 10. So you need to have that turned in as well. Okay? So really, if you're paying attention to that, we're only 1 day behind, and I'm not too worried about that. Alright, because I planned in time for like buffers. Now, one thing I'm going to do, I'll pass back homework. I'm trying to get to the habit, if you got a check mark on your homework, that means you got full credit on it. Okay? Some of you may actually have numbers written on it, but that's just because I used the right numbers, I'm just going to check mark.
So this is the homework.
Yeah. We're doing the rest of that.
I don't read Bible. You read.
The circle ones that she's on work, and kind of like in Kelly, and full credit work. I think everyone has that. Alright. Remember guys, this paper, I want to give you guys full credit for this, so make sure you're correcting the circle ones and whatnot. Help us training for it. We'll have to do Friday.
Yeah, I'm coming in that.